when we were talking about domains and ranges, alright, ladies and gentlemen, I need you to pay attention because, honestly, when I gave you that domain and range worksheet the other day, it was horrible. You guys did a pretty nasty job on that, even though you had on you had total access to the internet and everything like that. Now, as far as domain and ranges go, if we're just going to kind of break this down right off the bat, for domains, we're going to talk about X values or inputs that can be used. So all the X values that you can put into an equation are the X values that we're going to be able to use. Now the range are your Y values your function values or you can think of them as your answers. Now, a couple things that I didn't like when I saw the work that you did with that worksheet that had all those different parent functions. One, you didn't graph them very good. So when you have a graph, you want to graph them as best as you possibly can. Now, for example, if we just do y equals x squared, now, for y equals x squared, this graph is going to have a vertex here at 0, 0, 0. So 0, 0. With an x squared graph, the nice thing about that is if I go 1, 2, and 3 on one side, symmetry is going to get me the same points on the other side. So if I put in x equals 1, what's 1 squared? 1. So that's going to give me this point right here. If I put in a 2 for x, 2 squared is what? 4. So for 2, that's going to go up to 4. And 3 squared, 3 times 3 is 9. So for 3 squared, that's going to get me right up to here. Now, as long as, you see I'm going plus 1 here, and then plus 1 here, and plus 1 here. Alright, that's a little bit better. As long as I'm going the same amount in one direction as opposed to the other direction, subtracting 1 there, subtracting 1 there, and subtracting 1 there, I'm going to get that point 2 from there, 2, and that's 3, 1, 2, 3. And so my graph will look like this. So if I'm asking you to graph, I need you to be able to plot some points and get some points on the graph and get an actual picture of it, because I got some really, really weird stuff when you guys grabbed. It was just like you saw a picture and then you just kind of drew squiggly lines on the page and you made it look like that. That's unacceptable. Absolutely unacceptable. Not only do you have technology like this, I'll show you how you can use this in a second, but you need to be able to, one, figure out how to graph this and get an accurate graph, because then you can get domain and range from this. Now, if I ask you for the domain, which might happen on Wednesday, quiz. Obviously, since I just told you there was a quiz Wednesday. Now, first thing you look for, and the biggest thing is, the question you say, are there values of x that make this undefined? Is there what I like to call problem children? Are there any problem x's that are going to make this undefined? And the biggest thing that you want to look for, a square root of a negative number or dividing by 0. Is there an x value that's going to make, if I plugged in an x value, am I going to get a square root of a negative number at all if I'm squaring it? No, because I'm squaring it. So I'm not even using a square root. Am I dividing anything here? No. So are there any x values that I can't put into this equation? No. So my domain are going to be all real numbers. Now, no, that would have made it a whole lot better. Yeah, I tried to focus and I hit the wrong button. I apologize. Let me zoom out just a little bit. Now, we're going to try and find our range now. Now, we look for the y's. Here's what you want to do. Look. Look for y values. All right. So what you want to do is you want to look at the graph, and if you have the graph, you want to look for any y value that's not going to work. Now, if I looked at the graph, does 0 work? Am I going to get a part of the graph? If I drew a line at 0, am I going to hit the graph? If I drew a line at 4, do I hit the graph? At 6, do I hit the graph? At 8? What about at -4? No. One way that you can do this visually by the graph is wherever the graph is, you can highlight that part of the y-axis, and then for the range, now what's the smallest value? 0. So have we gone over, well, we could say 0. Can I be equal to 0? Now, what's the biggest value? If I put in 1 billion for x, what's it going to be? 1 billion squared, which is a lot. If I put in 1 billion squared for x, that'd be 1 billion to the 4th power. I mean, that's a lot. So it's going to infinity because the y's are going to, if I put infinity in there, it'd be infinity squared. And infinity squared is a whole lot, isn't it? Now, another way that you can write this is 0 to infinity. Well, you can't have brackets with infinity, but you can have parentheses. A bracket means we can equal 0. Yeah. From like 1, 2, 3, 4, -1, -2, and all the fractions. Everything, square root of 7. Soon as everything that doesn't have an I in it. Remember when we dealt with I with the square roots? Basically, everything's a real number, except for when we have I, because then they become imaginary or complex numbers. All right, so now, here's a graph. I want you to figure out the domain, and I want you to figure out the range. And you have 30 seconds. All right. Now, are there any x values I can't use? Well, doesn't this look like the x squared a little bit? Were there any x values that I couldn't use? No. So, all real numbers for the domain.
Is that the sign for all real numbers?
Yeah, it's like an R, but with a second line by the R. Now, for the range, what's the smallest value for the range? -4. Now, is the range going up or going down? It's going up because the graph is going up. So I can say -4 is less than or equal to y, which is less than or equal to infinity. Or actually, it's less than infinity because you can't be equal to infinity. Or you could say this. -4, comma, infinity with the parentheses. The bracket says I can equal -4. This means I don't equal -4. Now, if you wanted to, you could also have a different color here and highlight the ones that you can't use. No. Yes. Now, let's take a look at this guy. Now, this is a line. The first two are parabolas. If you noticed with the parabolas, the domain was always all real numbers, right? And if you have anything that's x squared, you're going to have all real numbers. But your range is always going to start at the vertex and move either up if it's opened up or down if it's opened down. So that's going to work for all your parabolas. Now for a line, are there any x's I can't use? So the domain's all real numbers. Are there any y's I can't use? No. All real numbers. So for a line, your domain and range are all your real numbers. Well, this line is going forever. That's what the arrows mean, right? So it keeps going and going and going. Now, if I'm at -10, am I going to hit the line? If I go down even farther to some weird number and go out here, am I eventually going to hit that line? Yeah. Is there any place where that y, can I find a y that's never going to hit the line? No. Not when it's a line, because it's going forever in this direction and forever in that direction. There are no holes. if there's a hole in the graph, it would have been shown. Now, out of all the x's here, is there any x's where it's not going to work?
Yeah.
Where?
Positive. All positive numbers.
Well, at 2, it hits the graph there.
Oh, I don't get this graph.
It's 2 parts. It's one graph. This is one big function, but it has 2 parts. This is a rational function. So it's like something over x plus a or whatever. Now, what value of x is not going to hit any graph? 0. You could say all x's, but x equal to 0. Or you could say x is not equal to 0. Because here, the graph is getting really, really close to the x-axis. Or when x is 0, the graph is getting really, really close to that part, but it's not hitting it. Here, it's not hitting it. Now, for the range, what value is not going to work for the range? 0. Same thing. Or you could say that y can't be equal to 0. Because then, when y is equal to 0, I have all the negative y's are taken care of by this branch. All the positive y's are taken care of by this branch. This is going to get closer and closer and closer to 0, but it's not going to get there. It's going to get closer and closer and closer to 0, but it's not going to get there. It's going to go all the way up to infinity because the arrow tells me it's going to. It's going to go all the way down to infinity because the arrow tells me it's going to. But it's just not going to get to 0. No, because no matter what number you have, there's always space between that number and 0. Yeah, it's like if you and it's the weird part of math that kind of, if you think about it too hard, your brain starts to hurt. If you have this, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I could always write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can always add another 0 in front of the 1. I can always add another 0 in front of the 1. I can get closer and closer and closer and closer to it without ever actually getting there. And that's one of the things that your brain just goes, what? All right, now, if I gave you this, and asked you, what is the domain? You don't need to graph it. Now, we have a division problem. What can't we divide by? Can't divide by what? 0. So, if I take that 1 over x plus 2, this can't be equal to 1 over 0. Right? So what part of this can't be equal to 0? That part can't be equal to 0. Subtract 2, x can't be equal to negative 2. So I found out that because it was x plus 2, if I put a negative 2 in there, it'd be 1 over 0, and I can't do that. We can't do that. Now, what about the range? Is there any number that you can't get? Here's the big thing. When you have a rational like this, ask yourself this for range. Can we get f of x equal to 0? Is there any way to make this equal to 0? Is there anything in the top? No. So my range all y's except for 0. And one last one I'm going to show you before I give you your homework over for the break that's due when you walk in. Now, if you have a rational expression like this, this is the easiest way to figure out domains and ranges. Now, for your domain, we can't divide by 0, correct? So I'm going to set x minus 2 equal to 0, add a 2. Well, I'll say not equal to 2. So x is not equal to 2. So my domain is going to be all reals except x equals 2. Now for the range, you almost do the same thing. I'm going to take x plus 2, and I can't have that equal to 0. Actually, that's not true. We're finding something else there. I apologize. Now, take that 2 that we had. Take that x plus 2 for the range. X plus 2. Now, where is that not going to hit? Well, in that case, why don't we just dump it into the calculator and check it out? Let's put a graph in here. X plus 2 divided by x minus 2. Now, what y value is it not going to hit? If you take a look at this graph. Well, an easy way to figure that out is hit Control T. Where is the y value undefined? So I know that x can't be equal to 2. Well, there's not a hole. What? Right there? Well, if I went over to here, and move that down, there's really no hole right there. Now, here's an easy way to figure out what your range is. When these two have the same powers, take these two numbers, whatever's in front of the x and whatever's in front of the x here, and divide them out. 1 over 1, that's going to get you to what? 1. So y can't equal 1. And that gets you with your horizontal asymptote. You got to remember how to get your horizontal asymptotes, which we talked about when we did rational expressions. But I'm running out of time, and I can't really go back into